Morning, students. Today, let us all see finite automata. Let me share the screen. Today, let's see finite automata, right? So, as you all know, automata plays a very, very important role in our theory of computation and compiled design subject. It is the base of everything. I am Dr. A.K. Jaijanbi, Assistant Professor from the Department of Computer Science and Engineering, RMD Engineering College. Right. Now, what is FA? Finite automata. It is one of the mathematical models that consists of a number of states and edges. It is a transition diagram that recognizes a regular expression or a grammar. There are two types of finite automata, non-deterministic finite automata and deterministic finite automata. So as you all know by the name, deterministic means it will have determined number of states, and for every input there will be one transition. Whereas in the case of NFA, for any input, there will be more than zero or more number of transitions. Now, NFA stands for non-deterministic finite automata. It is easier to construct NFA than DFA for a given regular language. The finite automata are called NFA when there exist many paths for specific input from the current state to the next state. Every NFA is not DFA, but each NFA can be translated into DFA. NFA is defined in the same way as DFA, but with the following two exceptions. It contains multiple next state and it contains epsilon transitions. In the following image, we can see that from state Q0 for input A, there are two next states, Q1 and Q2. Similarly, from Q0 for input B, the next states are Q0 and Q1. Thus, it is not fixed or determined that with a particular input where to go next. Hence, this is type of FA, you call it as non-deterministic finite automata. Now let us see the formal definition of our NFA, right? Basically, it is 5 tuples, right? So your Q1 is a finite set of states, right? It will be from Q0 to Qn. Your sigma is the finite set of input alphabet. Delta is a transition function that maps the state symbol passed to a set of states. Q0 is the starting state and Fn is the final state. Next, the second type of FA is DFA. DFA refers to deterministic finite automata. It refers to the uniqueness of the computation. The finite automata are called deterministic finite automata if the machine is read and input string one symbol at a time. In DFA, there is only one path for specific input from the current state to the next state. So DFA does not accept the null move. That is, DFA cannot change state without any input character. DFA can contain multiple final states, right? And it is used in lexical analysis of the compiler. Now let us see an example. In the following diagram, we see that from the state Q0 for input A, there is only one path which is going to Q1. Similarly, from Q0, there is only one path for input B going to Q2, right? So this is deterministic finite automata. The formal definition of DFA is, as you saw in NFA, it is basically a 5-tuple one where QD is a finite set of states and sigma is a finite set of input alphabet. Now, delta is a transition function that maps state symbol passed to a set of states. And Q0, as in all the type of automata, Q0 will be the starting state and FD will be the final state. Whatever be the automata, you'll be having a starting state, you'll be having final state, then there will be certain transitions. Only the way the transitions are done varies and the type of data structure we use. Okay, so we have seen about the formal definition of NFA and DFA and an example for both NFA and DFA in this session. Thank you, students. In the next session, let us see the problem of converting the given regular expression to NFA and DFA. Thank you, students.